welcome to this talk where I'm going to cover everything you need to know about Angular resources. So, as you know, Signals came out with Angular 16 a couple of years ago, and Signals are slowly making their way everywhere into the Angular framework. And so resources are one of the pieces that fit into that picture of making Angular a signal-driven framework, I would say. So in this talk, we're going to see everything you need to know about resources, why they matter, why they're important, and where they fit in that Angular Signals story. So before I get started, just a few words about myself. My name is Alain, or just Al. I'm a Google developer expert in Angular and Google Maps, also a Microsoft MVP in web technologies. I've been working with Angular for a very long time, started back in 2011 with AngularJS, and I do consulting and training at angulartraining.com, which is my main company. And I've been speaking at conferences all around the world, on all continents, except Antarctica, giving talks about Angular, web technologies, testing, and all of these topics that I really like. So, first thing is, it's important to remember why signals are important and why the Angular team is investing so much time and effort into these new APIs that are signal-based. So there are really two main themes around why signals are important. One is change detection. When you use Angular today, the default change detection mechanism is that when anything happens in the browser, so you click somewhere, you have an HTTP request that completes, or any event that happens in the browser, we have a library called zone.js that's going to catch that event, and that's going to tell Angular something happened, right? Something happened. And so then Angular has to figure out which component has changed, if anything. Maybe nothing has changed, but still it has to check every single component one by one from top to bottom, right? And that's our default change detection strategy. Now, this works very well. It's been around for a very long time, and it is very performant. But still, if you have a massive application with thousands of components and lots of reactivity, lots of things going on, you can imagine that there would be a better option, a way to make this a lot faster. And so with signals, that's exactly what we get, right? When you use Angular signals, the idea is that the framework knows exactly which views in our component hierarchy depend on which signal. And I say views because it's not the component, it's not the template of that component, it's really the smallest piece of UI that Angular manages, and that's a view, that's really a block. Like when you use a for block or an if block inside an Angular template, that's a view. And so if that view is the only piece in your Angular application that depends on a signal, then Angular will know that this is the only part of your entire HTML that would be refreshed when that signal changes. So as you can see, that's the complete opposite of where we come from, where we are right now. Because when you use a signal, Angular knows exactly the smallest part of HTML that depends on that value change, and that has to be refreshed as a consequence when the signal changes. Now I say signal singular. This also applies to multiple signals. So if you have different signals that change at the same time and they depend on several other views, Angular is still going to know that and refresh all of these things at the same time. So basically, it is so precise in terms of knowing what's changing and when that the Angular team started calling this not change detection anymore, but synchronization, because that's really what's happening. Angular is synchronizing the view, our HTML, with our data model described with signals. Now, this is really the future, right? And what the Angular team has been working on for quite some time. And it already works in Angular if you use signals everywhere, right? Because if you want this to apply and work across your entire application, it means that you just need to use signals. And so all of the APIs, all of the changes that we've seen in Angular over the past 2 or 3 years now go in that direction of enabling what we would call signal-based components, where everything in our components is a signal. The inputs, the outputs, two-way data binding with models, the content queries, view child, view children, content child, content children, all of these have been translated to signal APIs. And so once we get to that point where everything is fully signal-based, as you can imagine, we can remove that zone.js library, and we could do change detection 100% without that, because Angular just knows what changes and what to update as a consequence. And the other benefit is that RxJS can slowly move away and get in the background, and we don't need it that much anymore at that point. Because when you think about it, in a basic Angular application these days, the only place where we cannot really avoid RxJS is if you have to make an HTTP request, right? If you use the HTTP client from Angular, it returns an observable. And so you have to deal with that, right? You have to subscribe, get the data, work with that data. So that's really the next steps, right? In this signals journey of the Angular team is to make it possible for us to use signals instead of observables to deal with HTTP, HTTP client and things that come from a server, and basically have alternatives to RxJS in all of the APIs of the framework. So, of course, in the meantime, we have tools to enable RxJS interoperability. The most important one is the toSignal function that has been around since Angular 16. And so this already allows you to convert an RxJS observable into a signal, right? And there's the opposite function, toObservable, that just takes a signal and turns it into an observable. Now, the thing is, when we think about it, there's a key difference between observables and signals, because a signal is synchronous. It always returns a value immediately. We don't need to subscribe. We just say to the signal, hey, give me that value. We call it as a getter, and we get a value immediately. Now, that value could be undefined, or an empty array, or an empty object, but at least we always get something. We don't have to subscribe and wait. So it's very much like a behavior subject in RxJS. But when we make an HTTP request to a server, that's different, right? Initially, we don't have any value, and so we need a way to, the signal would basically have an undefined value initially and then get a value from that server. So with the toSignal function, there's a workaround that I use all the time, which is to pass a default value, an initial value, as a parameter when you use that toSignal function. And that way, you get into that mode where you ask the signal to give you a value, and it's going to give you something, even before that HTTP request completes, even before you get data from the server. Which, of course, is useful, but only really helps if we have meaningful default values that we can use. So the next step really to fill that gap is the introduction of resources. And with resources, the original idea is to give us a way to incorporate async data into our application signal-based code. So really make fit that asynchronous pattern into a signal-based approach. And if we go to the official documentation pretty quickly, we'll see that resource is a function. That function takes a number of different parameters. such as a loader. So loader is where we define how do we get data. So this is a base resource. It works with a promise by default. So fetch user would return a promise in that scenario. And params are any parameters that the fetching of that data would require. So here we say there's one param ID, and it's going to be the value of the user ID signal. These two things create a resource. And that resource is going to have a value. So I can do user resource.value, and that would return the current value of that resource once we get that asynchronous data downloaded. So how is that different from what we've seen before with toSignal, for instance? One key difference is that the parameters here, if you use signals in here, when they change, they are going to automatically trigger a new fetch of your data. So a resource can be connected to multiple different parameters, and when these parameters change, they automatically trigger a new request, right? They trigger fetching an update, which is pretty interesting because that's something we could do in the past, and we can still do now in Angular, but it would require using operators, using multiple RxJS streams and combining them together. Whereas here, all we do is say, hey, this resource, it depends on the user ID. And when the user ID changes, you just run that loader again, right? So that's pretty nice. So that's a default resource. On top of that default resource, we also have an Rx resource because, as I mentioned, resource is for promises, and promises are not that common anymore in Angular. So we also have an Rx resource, which is for RxJS observables. So you could use the Rx resource on top of an observable that comes from the HTTP client. That would work, but it's not ideal. Why not have something else that just replaces the HTTP client, right? That would be even better. And so that's what we have now, because with Angular 19.1 or 19.2, I think, HTTP resource came out. It's an experimental API, just like resource and Rx resource. All of them are experimental, but the good thing is that the HTTP resource simplifies everything, to it's a very minimalist API. It's very easy to use. And so if all you need to do is one request to a server and get some data, you can do it in one line of code, just like this. So you call HTTP resource, you can specify the type of your data, of course, using a generic TypeScript type here. Then you provide the URL where this is going to go fetch data, and that is it. You're done at that point. You have everything you need, and that resource is going to fetch the data, and it's going to give you different statuses on, is the data loaded? Did we get an error? Do we have a value? Is it still loading or not? Is it completed? All of these sorts of things you'd get access to with a simple API. So what's nice about this is no more visible RxJS. So there's no observable that we can see here. No subscription, no operator, which means no async pipe or no strategy to unsubscribe from these observables. Now, a resource, and all of these resources have returned an object of type resource that has the following signals exposed to us. Value is a signal that's going to give you the current value of that resource. Would be undefined by default if we haven't received anything yet from the asynchronous data source. There's a hasValue method that would return true or false. Do we have a value or not? There's an error signal that would give us, did an error happen in the process of fetching that data from the async source? Is it still loading or not? So is loading, and status. And status is just a generic object that can give you more details about the current status of that resource. So everything you need, right, basically. And I know that in the past with HTTP client or any other async data source, we would try to figure out these different statuses on our own, right? By adding different callbacks, by adding an HTTP client watcher to see the progress of our HTTP request, or those sorts of things. We don't need any of that anymore. All of these statuses are given to us by default on that resource object, which is, I think, really nice and a big improvement. So let's take a look at an example. I'm going to go to that stack blitz here. And the goal of this application is to display a simple list of items that come from the server. So I'm using a resource to do that. So I'm importing HTTP resource and using it. This is a request that we make to a backend server. And as you can see in my TypeScript code, that's what I have. All I do is create the HTTP resource, nothing else. If we go to our templates, let's go to the HTML for that component. We check if the resource is loading, and that's to display, an animation, a spinner in the meantime. So if resource is loading, we display that spinner. Else, we just iterate over the value coming from that resource, which is typed, right? We saw that in TypeScript. It's going to be of type user list, and user list is going to be an array of users. So everything is strongly typed here, which means Angular can help us autocomplete and check that we're doing the right thing with that data. And that's it. All I need to do is read the value from the resource. No subscription, no async pipe. And as you can see, my data is displayed here. So it's working. I can try a quick refresh, see if we have some, if we see the spinner showing up or not. Loading, spinner, and we see the data. So it showed up for 1 second or less. So this shows us that this works, right? And of course, if I wanted to handle errors, I would just do the same thing, add a if block, check the error signal, and if we have an error, then we could decide to display an error message or some other, some other component potentially to display that something went wrong. So that's a basic example. And just that is very useful, right? This is easier to use than the HTTP client for that simple scenario. But the thing is, it gets even more interesting for complex scenarios. So now I'm moving to a different example, which is the same data set, but now we have pagination on top of it. So we have a list of people, and we want to be able to navigate between different pages. So we have a previous and next button. We can change the page size here. And these things, these different buttons and drop-downs, they actually control signals. So we have a page signal, which is the current page. So by default, it's 0. And the page size signal, which stores the current page size. By default, it's 10. And that's what we see here. So 2 different signals that are going to be changed when we click on these buttons. I can show you the HTML quickly. So for the page size, just using ng model to update the value of that page size signal. And for the buttons, on click, we either call previous page or next page. And previous page, next page, update the value of our signal using the update method. And we also have some logic to not go below 0 or not go after the last page, so to stay within the bounds of the navigation. So that's the only logic we have. All we do is update signals, right? I'm not saying, hey, run a new request when we click on that button. I'm not saying go to a server and do something. I'm not calling a service or anything, just updating that signal. And if I click on those buttons, you see that it's working. I can change the page size. We have 5 items. Then you go 20, we get 20 of them. Let's go back to 10. I can navigate between different pages. You see the loader shows up sometimes in between those clicks. We see the spinner showing up very quickly. So everything is working. And my template, interestingly enough, is the same as before. I have a is loading on my resource to display the spinner, and I just read the value of my resource. So how does that happen? How does the magic of making a new request and displaying that new data happens? Well, it's actually super easy. The only thing I changed compared to the previous example is that my HTTP resource here, instead of getting just one string as a parameter, it now has a function. That function returns an object, and the object here has a URL property, and that URL property is a string, but that string, I built it by reading the values of these different signals. So I read the page size here, and I read the current page. So these two signals, driven by our buttons down here, they are dependencies of the resource. And so when they change, they automatically trigger a new request to that updated URL with the latest values of these signals. So that's super powerful, right? Because that's really all I need. In terms of lines of code, all of the business logic of how to change pages and all of that stuff fits in just a few lines of code, and then signals take care of all of that reactivity for us. So yeah, if you want to do the same thing with RxJS, it's more painful. You would need to have a few observables, you would need to combine those with operators, it would be tricky. But with signals, you just read the values and then the magic happens. So that's what I really like about this approach. And that's why I think HTTP resource is a game changer, right, for the future of Angular. Because once this is not an experimental API anymore, once this gets released as a stable API, I would just use it everywhere, right? And instead of using the HTTP client. And that would start replacing a lot of complex code in our applications and make things a lot easier. So that's one reason to get super excited about it. Of course, it supports other scenarios. Here, I'm just updating the URL based on Signal. This would work if you're posting content to a server and you want to change the body, and the bodies depends on signals. If you use URL parameters, if you want to change HTTP headers based on a signal, all of these scenarios work and are 100% covered as well. So yeah, HTTP resource really something super important for the future of Angular. I have to admit, I started using it in production projects, even though it's experimental, but that's just because I'm too excited about it, and I think I don't see how the API could change that much between now and the stable release. So yeah, I already use it in production. So that's really the essence of what I wanted to talk to you today about these resources. They're going to be a key thing in the future of Angular. Take a look, play with them, try them on sample projects or things that you don't plan on, deploying to production just yet. Yeah, it's worth it to get on that train, and it's going to help you in just a few months to get more familiar with them and get used to them. So that would be my recommendation, to just keep practicing and dive deeper into these resources. Before I conclude this talk, just wanted to quickly mention that we are running an Angular certification program at certificate.dev/Angular. This was designed by myself and a team of Google developer experts. We validate your skills for Angular certifications and validate your Angular background. If you're interested, feel free to take a look at the website. You can get in touch with me if you have questions or anything. And yeah, I just want to thank you for your attention. Thanks for attending. I put all of my contact info here, email, blog, newsletter, and I hope you enjoyed this talk and learned a few things about Angular resources. Thank you.